Hi everybody, and welcome to our today's session, use case for Data OS. I'm jumping in for another speaker today, so it's gonna be a bit improvised, but I hope you will enjoy it anyway, because I would bet that you probably didn't hear the notion of Data OS too much at this conference today, so that's something different for a change. So what is Data OS? Data OS is a new way to harness the power of your data. Well, that's kind of a marketing slogan, of course, but let me try to explain you what it is by analogy. So you probably heard a lot about different concepts such as, for example, data mesh, which deals a lot also now with the kind of organizational part of all this new and expanding data space. And I think that's very important to also look at this whole situation from the people side, from the organizational side. But the data mesh also moves the focus a little bit away from the technological part. But the technological part of this data space is not getting easier. It's developing. It's getting more differentiated. You get a lot of new different technologies where before you maybe had a relational database, analytical database, and a data lake. Now you have all kinds of streaming data sources, streaming processing. So the technological part of this whole picture is developing, is getting more complex, more vendors, more technologies, and something which I think is becoming a need now, and this is what we also hear from our customers, that is becoming a need, is to have a layer, an additional layer. Like 2-3 years ago, people would say an added layer of complexity, but now we hear more and more that people are saying an added layer of simplicity. And this layer of simplicity actually works in a similar way, the way you would expect it from an operating system on your PC. So just imagine on your PC, you have lots of different technological components. You have like CPU, you have graphical processor, you have keyboard. I mean, I will not name them all, but they're all very different. They work in a different way. They all do their job. And the good thing which you have also on top of all this is you have your operating system, because your operating system hides all the technical complexity behind the scenes, and it provides you as a human, or also the applications which you are using. It provides with the abstraction layer, with a simplified and unified interface, which you can use to implement your use cases, to work with your applications, to do your business without thinking too much about how the bits and bytes underneath the cover of your laptop are working. So that's what OS is about. And now moving from like classical OS to Data OS, this is the same thing, the same vision which we have for working with data going forward. And as you probably have guessed by now, this is something which is made possible by Data Virtuality platform. And the technology behind is something which we call advanced data virtualization. So why advanced? I mean, certainly a marketing way to describe something. But let me go a little bit down. What does it mean? So data virtualization, like generally speaking, the term is not new. I mean, term data federation was used before, and it was traditionally very much oriented towards using SQL language to run distributed queries across multiple databases or data sources. So that's not you. Basically, you just run select and get your data from all the different databases and sources in one result set. Simple as this. So what is advanced data virtualization? Advanced data virtualization uses the fact that SQL, although it's not a new language by far, but it's still very much used and continues to be used more and more. It's in fact the most popular second language in the technical space. And the idea of advanced data virtualization is to kind of hide all the different technical ways of integrating the data behind the abstraction layer of SQL language, which is easily understood by both people, by analysts, technical people, less technical people, but also by all kinds of applications, starting from self-service BI applications, but also from any self-made Python application and so on. So basically, advanced data virtualization means that you have one single SQL interface to your data, and you can query data live. You can move data from one part of your virtual database behind the scenes to another part of virtual database behind the scenes. So being a technical guy, I mean, just an example for technical people, you can do something like select star from Salesforce account into Snowflake account, and it will just work. It will do complex things with the APIs behind the scenes, but for user abstraction, it's just copy with SQL statement. And that's what advanced data virtualization is about. It's not, of course, just simple moving the data. It includes streaming and CDC capabilities, and also includes intelligent component to help you choose the right data integration approach. One more zoom level underneath the hood. How does data virtuality work like? So on one side you will see, so the picture in general is pretty traditional. So on one side you will have all kinds of data sources, data warehouses, data lakes, streaming sources, and so on. On the other side, you will have all kinds of data consumers, and like a typical operating system, data virtuality provides both its own components for doing some tasks, for example, a data catalog, but it also provides interfaces, standard interfaces like ODBC, JDBC, REST API, or data, to also feed other applications, external applications with data. Apart from this, it also provides metadata interface to interface with external metadata tools like data catalog tools and so on. So this is basically what's happening around the data virtuality platform. Now, what's happening inside data virtuality platform? Inside, you will have two main components here in the middle, and the central component is a virtual SQL engine. This is an engine which can execute SQL language statements across different databases. It can move data across different sources and so on. So it can work with data using SQL without storing the data. In addition, you also optionally can connect analytical storage. Analytical storage is basically just any kind of analytical database which you connect. And data virtuality will use this storage for the cases where you do need to store the data, to persist the data. For example, if you need to do data cleansing, any kind of master data management, or just load batch data and historize it over time, for example. Also, this analytical storage is capable of materializing the things which you build in virtual interface. So here in the virtual part, you can build your data models, which can be done as virtual views or virtual stored procedures. And this analytical storage is used to materialize this data to increase the performance of your models. So this is how it looks on the technical side. What is it good for? What are the special things about it? So it supports modern data architecture such as data mesh, data fabric, and so on. It is also capable of supporting different types of use cases. So one important aspect here is the combination of analytical workloads, which can be run on the system, but also operational workloads. Operational workloads can be real-time reporting, or it can also be feeding your mobile applications with data, and I will be talking about some use cases later on. This is also something which you can use to create a hybrid or multi-cloud data ecosystem, because this virtual layer can help you span different clouds or also span your on-premise and your cloud systems. And it also can help your data people, for example, data scientists, get easier to the data from all the different systems. So let's look at some case studies. What can this be used for? So one of the case studies is our retail banking customer, and they really started into the journey by looking at their customer data and their marketing data. So they had their existing data environments, their data warehouse, and their data lake, where they had lots of data, but they still didn't have all the data which they needed. They didn't have data from CRM systems, from marketing systems, from web analytics systems, and so on. So they started really by analyzing and connecting their customer data, which is like marketing analytics, customer analytics, which is pretty simple use case. Then in the next step, they realized that they can also use the data provided by the system for risk management. So they started feeding the data from this system to their risk management department to improve their risk models, to make their credit offers work better. The next point, which is also very popular in the financial space, especially on the continent, is data preparation for regulatory reporting. So European Central Bank is putting a lot of pressure on the European banks to deliver quicker, better, and more data. And this is where this bank felt they cannot be up to speed with the existing data environment, and this is why they took this data OS environment to provide the results to the central bank quicker. And another thing which was also not a typical thing for your data warehousing environment was the real-time monitoring and sales management of their online sales platforms. So they are selling different consumer loans, consumer credits to different customers, and it's a very quick-paced business. So at any moment of time, the situation on the market can change. So there could be different offerings from different customers, from different competitors. So there's always online comparison going on to find the best loan offer. So how does a retail bank make sure that at any given point of time they are providing the best offer so that the customers are taking their offers and not the offers from somebody else? And they did it with real-time reporting, with real-time monitoring, using data virtuality, using their online sales systems, of which they have multiple, connecting this all with real-time data, connecting with the historical data about customers, and providing the sales team with a real-time monitoring cockpit so that they can see in real time how their sales are developing and that the sales can react to real time, because this is something they need in their business. Looking into another case study, that's asset management, one of the larger Swiss asset managers. And they actually started the journey into data OS from a different perspective. They started with the understanding that they have a lot of different operational systems where they track and manage their assets. It's a kind of multi-boutique approach. And they realize that the data they provide to their customers not necessarily have the quality that the customers expect. So they had a lot of complaints about this. And this is where they realized that by introducing a virtual layer across of their operational systems, but also across the systems which hold their historical data, they are capable to control and gradually improve the quality of the data in all of the environments. So that's not the usual approach when you start from reporting use cases, but they really wanted to have data OS to keep those rules, which can be easily defined in this virtual space, to understand how the data in one system, like the customer count or any kind of sums or any data about the assets, how the data from one system correspond to the data in the other system. And they wanted to understand this both in real time, but also in the historical perspective. So for example, they wanted this system to be able to alert them, for example, the data which they're sending to regulators or to their customers had any significant deviations. And they use the system to build up their set of data quality rules to continuously control these quality rules and to improve the data as it goes. And for any new error in the data, they would create a new rule to continue checking and improving the data. And this was a starting case for them. And from this point on, they also added use cases like reporting, marketing analytics, regulatory reporting, and so on. So that's interesting that the customers are really coming in from very different perspectives, but they end up implementing a multitude of use cases. In the data mesh lingo, we would say multiple data products on top of this platform. This is another use case. That's a pension. That's a pension fund. It's one of the largest world pension funds, and their approach was again a totally different one from a different perspective. And they took actually a more strategic approach. It was not really about implementing some initial use case and then building it up, but they looked at it from the strategic perspective. So they had strategic goals. One of their strategic goals was to gradually start moving the environment to cloud, and they understood they could not do it at once. So they understood that they will need to run a hybrid environment for a very long time and possibly even forever. This was one of their like strategic incentives, and the other strategic incentive was that they wanted to have a very good data governance, and they wanted to improve their data cataloging capability. And you will see some vendor names there. But one of their premises was that they did not believe in the data catalog living separately from the data, because they said we were talking to people in the industry, and basically what we usually saw, there is data catalog, it's being built for some regulatory need, and basically when it's needed for regulation, it's getting updated. But apart from this, the data in the data catalog and the metadata catalog is not necessarily up to date, because there is no technical connection between the metadata and descriptions which are in the catalog and the real data which you actually get from totally somewhere else. And their wish was to have the source of data and the source of metadata tied together in a kind of single architecture. And this is what they did. They are running a hybrid environment with Snowflake as their cloud data storage, but also with a number of internal data warehouses and systems which they need to keep on premise. And also they have a combined environment with enterprise data catalog and data virtuality as a data provider, where they can get the data itself, but also all the needed business metadata and also all the needed data lineage from the same single source. Another case study is again an interesting combination. So it's really never a single use case. That's an international payment provider, and one of the things which this payment provider does, it also outsources. It also provides to the banks, to the client banks which they have. They provide a service of selling loans in a different ways. And for this, they built a system on top of data virtuality. And the key components of this system are that on one side, they have all the different sources of data, which are coming from the internal data or also from the external data. They also have a team of data scientists which build their models based on this historical data, and they build it using Spark and different technologies on top of Spark. They also have business analytics team, which uses Tableau to run the dashboards and the analysis. And they also developed and connected to data virtuality an app, a mobile app, which is the instrument for their salespeople, which go and sell loans to small businesses. And basically what it means that a salesperson goes into the customer premises, for example, could be a cafe, and it's offering the owner of the cafe, do you want to take a credit to renew your furniture, for example, or to buy a new bar stand? And if the owner is open to this discussion, then it's possible from this mobile device to directly enter on all the needed data, and all the data go from the mobile device to data virtuality, and it combines the real-time data from the different internal systems with the historical data which they have built, and it also uses the data models which were built by the data scientists to make like credit approval, credit pre-approval, to calculate the loan conditions, and they use this all information to answer in real time the request from this salesperson so that he or she can sell customer in real time. Yeah, so you may have probably noticed that the use cases I had with me are all from the financial services environment, but it doesn't have to be like this. We also have cases from other companies, for example, from healthcare. So one of the Canadian hospital networks is using our platform to both run the historical reports and the normal BI workload, but also to optimize in real time the patient occupation in the different hospitals which are part of the network. And this is very important that they do it in real time. And there are like two reasons for this. One is very humane and the other one is commercial. So the humane reason, because the patient really needs to go to get the bed basically in the closest time so that he get the best treatment. The commercial reason is that it's also getting controlled by the health insurance, and if it takes more time, then there's some limits to get the patient to his place, then the hospital network does not get paid. So there are more use cases also from different industries, but let me kind of wrap up and summarize why such a data OS could be useful in your projects. So first of all, it hides the complexity from you, the complexity of the data. So data virtuality provides more than 200 different connectors to all the possible things, like starting from SAP and going to all the data warehouses, data lakes, and then to things like online CRMs like Salesforce and all kinds of marketing channels. And you can use the same language, the same way of modeling the same data using SQL, and you can use it to create models. You can use this also to move the data. You can use it to historize data. And in our experience, and it sounds like marketing, but actually it's not. It's something which is proven by our customers, that it speeds up the time to delivery 5 times, so by 80%. And it's also easy to understand why is it so, because you don't need to have different skills to connecting to all the data. You just have one skill, which is using SQL, which is a common skill to get you started. You also don't need to think on how to move the data before you provide first results to the customer. It's very easy to do rapid prototyping in a live environment and iterate with your internal customer, with somebody who wants a report from you, an analysis from you, to iterate in real time. And then when your internal customer is satisfied, you can productionalize it by pushing a big green button and saying, okay, let's now put it into an analytical storage and serve it from there for 500 of other internal customers you have. You can have it as SaaS, but also on premises. So you can cut on providing your own environment, managing and installing it, but you can also do it if it's your requirement. And we also provide intelligent query and performance optimization. How can you imagine this? So since it's all SQL based, our system is able to track what you and your users are doing with the system. So what is being used oft and how, and you have a kind of AI-based DBA sitting next to you and giving you recommendations based on the observed behavior, how you could optimize things so that you can get even quicker results to your customers. Yeah, so that's all. That's data virtuality, markets first data OS. So feel free to talk to us also at our booth. It's booth 939. And also one kind of interesting announcement will be that at 14:00 today we will have data drinks. So I think there were some data drinks yesterday already. But if you didn't manage to get your drink yesterday, or just fancy having one more data drink, you can come to our stand at 2 p.m. today. It's booth 939. So if you have any questions, we'll be happy to answer them here. Thank you very much for your attention.